Let us show that a matrix is orthogonal matrix. Okay, so how to show that a matrix is orthogonal matrix? Let us start. This is a 3 cross 3 matrix which has been given to us. So this is it has 3 rows, 1, 2 and 3, and it has 3 columns, 1, 2 and 3. So that's why it is a 3 cross 3 matrix. Okay, and we have to show that it is orthogonal. So how to show? Let us see. So let matrix A be equal to 1 by 3, and this is the matrix which has been written as it is, and I have named the matrix as matrix capital A. I have named it as matrix capital A. Now let us find the transpose of this particular matrix. In order to show the orthogonality property, what we need to show? We need to show that for showing a matrix to be orthogonal, we need to show that A transpose, okay, A multiplied by A transpose will be equal to identity matrix, and that will be equal to A transpose multiplied by A. So this is what we have to show. If we are able to show this, then matrix A will be orthogonal matrix. Okay, so let us try to show that particular thing. So matrix A written as it is, then A transpose 1 by 3 outside, so it is written as it is outside. While taking transpose, what do you do? While taking transpose, the first row becomes the first column. Okay, so the first row has become the first column, the second row has become the second column, the third row has become the third column. Okay, so the transpose is equal to the original matrix in this particular case. In this particular case, the transpose has come out to be equal to the original matrix itself. Okay, so see it once again. This row, first row, has become the first column, the second row has become the second column, the third row has become the third column. Coincidentally, we have got A equal to A transpose in this particular case, but that is not equal. That is not important. A matrix A is equal to A transpose has come out, but that is not important thing. That is not the thing which we need to focus on. We need not focus on that. Okay, all we need to do is that we need to show this particular thing. So let us try to show A transpose equal to, now this 1 by 3 A multiplied by A transpose. While doing that, 1 by 3 multiplied by 1 by 3 will become 1 by 9. Okay, it became 1 by 9. Then I wrote the matrices as it is. Matrix A has been written over here, matrix A transpose, which was found in the slide earlier, it has been written over here. Okay, so A has been written and A transpose has been written. Both of them have been written successfully. So let us now multiply. So first row will multiply with first column. Okay, so element of first row and this first column, first element. Okay, so -1. So we are going like this from here like this. So this will multiply with this will multiply with this will multiply with this. Okay, so first row will multiply with first column. So this multiplied by this, what will happen? -1 into -1 is equal to +1. Okay, then 2 multiplied by 2, 2 plus 2, 2 multiplied by 2 is equal to 4. Okay, then 2 multiplied by 2 is equal to 4, so written over here. Okay, -1 multiplied by, now first row will go with second column. Okay, first row, it has gone with first column, already done. First column and first row multiplication already done. Now first row will go with second column. So what will happen? -1 multiplied by -2 is equal to -2. Okay, plus 2 multiplied by -1 is equal to -2. Okay, plus 2 multiplied by +2 is equal to +4. Okay, then what will happen? Then first row will go with third column after that. Okay, so -1 multiplied by -2. Okay, plus 2 multiplied by +2 will become +4. Plus 2 multiplied by -1 became -2. Okay, then second row will start. So second row multiplied by first column. So 2 multiplied by -1, -2, -1 multiplied by -2, plus 2 multiplied by +2, +4. Okay, then first row multiplied by second column. Okay, so 2 multiplied by 2, that is +4, -1 multiplied by -1, that is +1, plus 2 multiplied by +2, +4. Okay, so this is done. Then second row multiplied by third column. Okay, so 2 multiplied by 2, 4. Okay, -1 multiplied by -2, plus 2 multiplied by -1, -2. Okay, so this is also done. Then third row will go with first column. So 2 multiplied by -1 is equal to -2, plus 2 multiplied by 2 is equal to +4. Okay, minus 1 multiplied by minus 2 is equal to minus 2. Then plus, then third row will go with second column. Okay, so 2 multiplied by 2 is equal to 4, plus 2 multiplied by minus 1 minus 2. Okay, minus 1 multiplied by plus 2 minus 2. Okay, then third row will go with third column. Okay, third row will go with third column. So what will happen? 2 multiplied by 2 became 4. Okay, 2 multiplied by 2 became 4. Okay, minus 1 multiplied by minus 1 became plus 1. So this is what we got. Then 4 plus 1 is equal to 9. Minus 2 plus 4 is equal to 0. Minus 2 plus 4 minus 2 is equal to 0. Minus 2 plus 4 is equal to 0. 4 plus 1 plus 4 is equal to 9. 4 minus 2 is equal to 0. Minus 2 plus 4 minus 2 is equal to 0. 4 minus 2 is equal to 0. 4 plus 4 plus 1 is equal to 9. Okay. So what we get? A transpose is equal to 1 by 9 multiplied by 900 Now as soon as you take this 1 by 9 inside the matrix, as soon as you take this 1 by 9 inside the matrix, what will you get? 9 and 9 will cancel, 1 will occur. 9 and 9 will cancel, 1 will occur. 9 and 9 will cancel, and 1 will once again come. Okay. So A transpose came out to be equal to this 1 0 0 0 1 0 0 0 1. Okay. This is identity matrix clearly. So it is equal to I. It is equal to capital I. That is identity matrix. Similarly, in a similar fashion, this is your homework. Okay, I am giving you one homework over here. Okay, this is your homework. What is your homework? Your homework is that you need to show that A transpose A is equal to identity matrix. Okay, A transpose A is equal to identity matrix. This is your homework. Just show this. Just show this. This is your homework. Okay. So what happened? A transpose is equal to identity matrix. A transpose A, although we have not calculated, but it will come out to be the same. Okay, although we haven't calculated this particular thing, but it will also come out to be equal to I. You can check it. You can check it yourself. You can check it. Okay. So A transpose is equal to identity matrix is equal to A transpose A. So A is an orthogonal matrix. So that's why A is an orthogonal matrix. So because why is A an orthogonal matrix? Why is A an orthogonal matrix? A is an orthogonal matrix because it is satisfying this particular condition. As it is satisfying this particular condition, that's why A is an orthogonal matrix. Okay, so all the elements which all the matrices which satisfy this condition are called as orthogonal matrices. So if A matrix satisfies this condition, then A will be an orthogonal matrix. So this is how we have shown that A is an orthogonal matrix.